Now let's just confirm how many resources we have in our cluster that are running. To do that, you can just do kubectl get ingress, and then we are getting it from all namespaces. You can see we only have the default backend here. Now it's time to install our two other applications. To do that, we'll just do kubectl apply. We're applying a manifest file, so use option F, then enter the path using examples. Then we are installing Bloom demo first. And anytime before you apply this changes, make sure you check your application. While creating this manifest, I explained most of these sections, but just make sure you check it and make sure the certificate ARN is passed correctly, and also the group order and the group name are also passed in correctly. With a different group name, this resource will create a different load balancer, and then you will have to go and configure that load balancer separately. But for this case, we are using the same group name as the one we used for the default backend here, and also the one we'll use for this other one right here, so that they can share the same application load balancer. So Bloom lessons has been created. We can check all ingresses to just confirm it has been created. It has been added right here. Let's create the third one, which will be the game. So let's just check here again. All ingresses in all namespaces. Now we have 3 and all of them are sharing this load balancer. So we'll give the new ones a few seconds, up to a minute or so, for Fargate Compute to be ready. And then once the pods are running, we can access them. Once you install the default backend and it has set up the load balancer, the rest of these resources will be deployed much quicker because they won't have to wait for the load balancer to be active before they can serve requests. So once Fargate Compute is ready, the pods can immediately start processing your application requests. To know that the new applications are ready, we can just check for them by running kubectl get pods. We can get them from all namespaces too, so that we can check everything together. This will be a little bit verbose, so depending on how huge your cluster is. So for the app games, you can see it's running. For the Bloom lessons, you can see it's also running, which means the compute has been deployed already. So let's go to our browser and check the Bloom lessons demo first, and then you can check the game last. This is where we loaded the default backend. Then here we try to load the game. It went to the default backend, and also here we try to load the Bloom demo and it went to the default backend. Now if we refresh this, it should load the correct app like that. So this is the demo app for the Bloom lessons demo page. With this container, you can get the links to our channels. I encourage you to follow us on LinkedIn and on Facebook, and also subscribe on YouTube so that you can get posted whenever we release new content. Then when we go back to the game, which is our final demo, when we reload, to be able to load the 2048 tile game, and then we can start a new game because my browser had saved the old game, I think. And here you can see the instructions of how to play via this. This is the public version of the game, but we just installed it on our own cluster, and then you can see the credits to the creator right here. So we can play the game quickly and see if it functions. So we use the arrow keys. Let me know how long it took you to reach 2048 tile. I'll just continue playing, then I'll skip some repetitive parts. If you failed along the way, also let me know, and let me know what you think about the tutorial in general and also about the game. And I just failed. Thank you. That marks the end of the tutorial setup. Let's just review what we've covered and wrap it up.